Okay, now we're going to look at just simplifying some radicals. So the first one we have here is a square root, okay? So look at your list of perfect squares, and if you'll notice 20 is not on your list of perfect squares, but you do have the perfect square of 4. Just like I did with that previous example, if there's any number that's on this list, your perfect squares, that will go into 20, then you are expected to simplify it. So I'm going to rewrite the 20 as 4 times 5. Okay? Now let's talk about how to simplify the variables. So first of all, I have x to the 6th power. Now if you look at your list of perfect squares, you do have x to the 6th power on your list. So since it's already on your list, then you're going to leave it exactly like it is. Okay, now let's look at y to the 11th. Okay, so again, if you look at your list of perfect squares that are variables, actually what's supposed to be the next one on the list here after x to the 10th would be x to the 12th. See, it's going to jump right over x to the 11th, so, or y to the 11th. That's not a perfect square, so we're going to have to rewrite it, okay, just like I rewrote the 20. The way you do that is you find where it should be on your list, and you're going to drop down to the one that's just below it. So the 11 would fall in here. I'm going to drop back and use x to the 10th, or in this case, y to the 10th. But then I also have to include just a y to the 1st power. Now the reason why I have to include that is because I still need this to total 11. Okay, I'm just writing it different. It's still got to stay the same. So if I put 10 here, I have to put a 1 here to make my total of 11, okay? Now, what I have that is directly on that list, that's the 4, the x to the 6th, and the y to the 10th, okay? I want to concentrate on those first. We're going to actually take the square root of those. Now, the square root of 4 is 2, okay? So you do your numbers just like you always have. Now, square root of x to the 6th. The quickest way to figure that out that's easy to do in your head, since this is a square root, that means that I have an understood 2 right here. So I want you to do 2 into 6. And 2 will go into 6 3 times. So that means I'm going to have x to the 3rd out front. Now I'll do the same thing with the y. So I would do the 2 into the 10, which is a 5. So that means that I have y to the 5th out front. Now the stuff that I've not underlined, which was the 5 and the y to the 1st, that's just left underneath your square root symbol. Because remember that those things were not perfect squares, therefore I could not take the square root of those. Okay, looking at another one. Okay, so this time I'm looking at a cube root. Okay, so we're going to look at a different list of numbers this time. Okay, so if you look at your list of perfect cubes, so if you notice 54 is not in here. Of course, 54 would fall right in between the 27 and the 64. So do I have any of these numbers that will go into 54 evenly? And that would actually be the 27. That would end up being 27 times 2, okay? Now, the x is just to the 1st power. Now, if you look at your cubes, you notice the first thing on the list is a 3rd power. So if you have anything that's in front, there's just not anything you can do with it. So since this starts off with the 3rd power, and what I have in my problem is a 1st power, which, like I said, would fall before this list ever started, there's nothing you can do with it. You're just going to have to bring it down like it is. Now, next I have y to the third. Well, a third power is on my list, so it's already a perfect cube, so we're going to leave that like it is. Okay, now next I have a 10th power. Okay, let's go back to our list. Now, a 10th power is not on here. Actually, my 10th power would fall right here between these two. So just like I did a while ago, go to the one that's just below it. So if my 10th power is supposed to be right here, the one that's just below it is going to be this 9th power. So I'm going to use z to the 9th power. But then I know I also have to include a z to the first power, because if I put 9 of them here, I need one more to keep my total of 10. Okay? Now, the things that are on your list, that was the 27, the y to the cube, or y cubed, and z to the 9. Those are the things that I can take the cube root of. Now, cube root of 27. So this is 1 cubed, 2 cubed, 3 cubed. So that means the cube root of 27 is going to be a 3. So I'm going to have a 3 out front. Now remember, with the variables, do your root into your exponent. So 3 will go into 3 one time. So that means that I just have a y to the first out front. And now I do 3 into 9. So 3 will go into 9 3 times. So that means I have z to the third. So the 2 is left underneath, the x is left underneath, and the z is left underneath. So that would be your simplified form. All right, let's look at a fourth root. Okay, so go down to your list of perfect fourth powers. Of course, the number I'm looking at here first is a 32. Of course, you obviously 32 is not on your list here. It would fall in between the 16 and the 81. So check to see if anything below that will go into the 32, and it will, the 16 will. So we're going to rewrite this as 16 times 2. Okay, now let's look at our x. Now my x is to the 13th power. So a 13th power would fall right here between these two. So it's not perfect. So I drop to the one that's just below it. So that would be the 12th power. So I'm going to rewrite this as x to the 12th times x to the first. Because again, you got to keep your total of 13. Now, 10th power. So go back to your list. Your 10th power should be right here. So then you go to the one that's just smaller, which is the 8. So I would have y to the 8th, but then I'd also have to do y to the 2nd, because if I put an 8 here, I have to put a 2 here in order to have my total of 10. Okay, so the things that I have that are perfect are those three things. All right, fourth root of 16. So this is 1 to the 4th, this is 2 to the 4th. So that means the fourth root of 16 is 2. Okay, 4 will go into 12 3 times. So that means I'm going to have x to the third. 4 will go into 8 2 times. So that's y to the second. And then everything else is left underneath. The 2's left underneath, x to the first, and y to the second. Okay, let's do one more simplifying. Okay, so this time I have a negative underneath, and I think this is supposed to be a second power. That's the way we'll work it. It's one of those random dots again that I can't that it prints off. So make this x to the second when you put it in your notes. Okay, so having the negative underneath, remember, is going to be okay because this is an odd root, okay? Now, look at your cubes. And if you notice, 64 is already a perfect cube. So we're not going to bother rewriting that. So we'll leave this as negative 64. All right, now I have x to the second. Well, if you look at your cubes, see, a third power is the first thing that's on here, and x squared comes even before this list starts. So there's not going to be anything I can do with that. And now a 14th power would be here. So I have to go to the one that's just below it, which is the 12th. So that would be y to the 12th times y to the second. Remember, I got to keep my total of 14. So what I have that's on my list that's a perfect cube are those two things. So cube root of negative 64 is going to be a negative 4. And then 3 will go into 12 4 times, so that means I'll have y to the 4th, and everything else is left underneath your radical.